This is our IoT Goniometer, and it's made from a plastic goniometer, a Raspberry Pi, a flex sensor, and an analog to digital converter. The flex sensor is attached to two parts of the plastic goniometer and bends and straightens when the goniometer moves. It's most straight around 90 degrees and most bent at around 30 degrees. When running the goniometer web app on the Raspberry Pi, it creates a measurement interface where you input the patient's name and then select if you're taking a static or dynamic measurement. To take a static reading, we put in the patient's name, select static, and then click measure, and wait about 1.5 seconds for the flex sensor reading to be sent to the Pi. This reading is then converted to an angle using the goniometer calibration we got from measuring the angle on the goniometer and the ADC reading, and this angle is calculated and shown in the static page and also saved to a database using MySQL. We can then see previous measurements by going to the previous measurements tab, which shows the 20 most recent measurements, and we can also search by patient name. So typing in the patient name pulls the 20 most recent readings from that patient. To take a dynamic reading, we again put in the patient's name and select dynamic, and then click measure. This measures for 6.25 seconds and records 200 data points from when the patient is moving during this dynamic reading. These are also calculated to angles using the same calibration from the static, and this shows the dynamic reading page, which shows the maximum angle reached during this time period, and as well as a graph of the patient's movement during this time period. The graph shows the angle that the goniometer reached over time.